Today we're working on determining if a table is proportional or not proportional. We're going to work on number 3 in this video. So it says determine if the table is proportional, show your work to earn full credit. So I'm going to go ahead and get rid of those directions so I have a little bit more room. I'm going to move the problem over using this hand tool, and then I'm going to label X and Y using my text tool. So on the left, in a vertical table like this is X, so all of these values are X. And then all of these values in this right column are Y. And then I'm going to grab a pen color and then the scribble, and I'm going to start with this first point. And the Y value, you have to be very careful here, this is an important part, the Y value is 2 1/5. I'm seeing a lot of kids who are still mixing up where X goes and where Y goes. So Y is 2 1/5, X is 2. So take your time with this part, check it, make sure it is correct. This is a complex fraction, so we need to follow our complex fraction steps. And the first complex fraction step is to change the numerator and denominator to a fraction. So I'm going to grab a different color so you can see what I'm doing. I start by multiplying 2 times 5, and I get 10. And then I add the numerator. So I add 1 to the 10. And that becomes the numerator of my fraction, 11. And then the denominator stays the same. So it was originally a 5 over here in the mixed number. That's the only denominator in the mixed number is the 5. So it stays a 5. And then I'll draw a larger fraction bar. And then to change this 2 to a fraction, to change an integer to a fraction, you just put it over 1. I'm having a lot of people to make 2 a fraction, they write 2 over 2. 2 over 2 is actually equal to 1. So that would not be equivalent to 2. So don't write that 2 equals 2 over 2. That would not be correct. Write that 2 is equal to 2 over 1. 2 divided by 1 is equal to 2. Alright, the next mistake I'm seeing students make is they're not putting the numerator first. Make sure you write the numerator first. The 11/5 is the numerator. And then you write the denominator second. So we're changing this fraction bar to a division symbol. Put the numerator value first, and then you write the denominator value second. Then we're ready to keep, change, flip. So we keep this part, we change this to a multiplication sign, and then you can say flip or reciprocal. So 2 over 1 we would flip and make it 1 over 2. The next mistake I see students making is some students are flipping the first fraction. The first fraction is locked in. You don't change the first fraction. Leave the first fraction alone. It was 11/5, it stays 11/5. The division changes to multiplication, and the 2 over 1 changes to 1 over 2. So when you're trying to flip a fraction, it's the second fraction that you flip. And I get 11/10. I can't reduce that. I could write it as a mixed number, but I'm just going to leave it as 11/10. So I'm just trying to see if all the unit rates are the same. So the unit rate was 11/10 when I used the first point. Alright, for the second point, the Y value is 4 2/5, that goes in the numerator, and the X value is 4. Step 1 is to change this mixed number to a fraction, so I multiply the 4 by the 5, and I get 20. And then I add the numerator 2, and that gives me a new numerator of 22. And the denominator stays the same. The denominator stays a 5. Then in the denominator of this whole complex fraction, I have a 4. And to change an integer to a fraction, remember you put it over 1. So 4 becomes 4 over 1. Then write the numerator first, 22/5, divided by the denominator, 4 over 1. And then we keep the first fraction. So this is locked in. You don't change it. It stays 22/5. Then you change the division to multiplication, and then you record the reciprocal of 4. And I get 22 over 10 when I multiply the fractions. With fractions, we just multiply the numerators, multiply the denominators. Oh, 5 times 4 is 20. I don't know why I wrote 10. Excuse me for that. Now I need to reduce, so I divide each by 2, and I get 11 over 10. Now if this were different than this number, I could be done because I know it's not proportional, but so far it's proportional. So I do have to keep going and check this last fraction. All right, so we have the y value is 3 1/2, and the x value is 3 2/11. Step 1, you change each of these to fractions. So we're going to multiply the 3 by the denominator 2 and get 6. And then we add the numerator, the 1, and we get 7. And then you keep the same denominator from the mixed number. So this becomes 7/2. I use the same process down here. I multiply 3 times 11 and get 33. And then I add 2 and I get 35. And then you keep the same denominator, 11. So 7/2 divided by 35/11. So it's numerator divided by the denominator. The first fraction is locked in. You keep that as 7/2. So I just copy that, 7/2. This is where the changes occur. So I change the division to multiplication, and I record the reciprocal of 35/11, which is 11/35. And I end up with 77 over 70 when I multiply the numerators together and the denominators together. I recognize that 77 and 7 are both multiples of 7, so I can divide them each by 7. 77 divided by 7 is 11, and 70 divided by 7 is 10. The unit rate was 11 tenths, 11 tenths, and 11 tenths. So this is a proportional equation. So I believe on your paper that it says, is this proportional or not? And you would circle yes. So I'm just going to write down here the word yes and circle it to show, yes, this table is proportional because the unit rate remained constant.